All right. So, hello and welcome everyone. I welcome all of you to this amazing platform of Tutee learning. And today we're going to learn about another important concept in vectors, that is product of two vectors. Okay. So, in today's class, we're going to see that how we take the product of two vectors and what are the different methods, and also we're going to explore the geometrical implication or meaning of product of two vectors, right? So, let's get started. And if you're new to this particular platform, I would request you to please subscribe the channel and also hit the bell icon so that whenever we are live, you get a notification directly on your phone, right? So let's start. So if you have been following this particular channel for a long time, you must have knowing that we are basically trying to help students who are currently in class 12 and dropper, and they are basically preparing for the upcoming JEE Mains and Advanced examination for 2026, right? So students who are going to prepare for the upcoming mains and advanced examination for the year 2026, definitely this lecture series is going to help you a lot. All right, so with this, let's get started. And we have covered a substantial amount of topics in vector algebra, and also we are basically trying to move in the same direction, right? I hope the discussion previously is clear to all of you. So let's start with today's discussion, and today we're going to discuss about the product of the two vectors. All right, so let's quickly see that before we start, I want to discuss one more problem that is quite an important problem, and especially if you are for IIT examination, these kinds of problems are really interesting, especially in the concept wise, right? So the question says that if there are vectors like a vector is given as I cap plus j cap minus k cap. All right, if I have the following vector says I cap a vector is given as like this, b vector is given as, so b vector is given as 4 I cap plus 3 j cap plus 4 k cap, and I also have another vector that is c vector which is given as I cap plus alpha j cap plus beta k cap. So I have the following vectors as follows, right? So right. Now it is said that these three vectors are linearly independent. Oh, sorry, dependent. Okay. So these three vectors are linearly dependent vectors. That is what is mentioned in the problems, right? So it is said that these three vectors are linearly dependent vectors such that I have the magnitude of C vector given as square root of 3, such that I have the magnitude of this C vector as square root of 3. Right. So if I have this following problem in the question, it is asking you to find the value of alpha and beta. Okay. So this is the question. So you have to find out. So you have to find out the value for. So you have to find out the value for alpha and beta. All right. So in order to solve this question, we have to quickly see one interesting idea regarding linearly dependent and independent vectors. Okay, so let's try to explore this particular idea. What did we mean by linearly dependent and independent vector? And this is the previous year IIT JEE problem. Okay, so let's try to see the solution for it. Okay, so if I talk about that, I have, let us say, I have three vectors, A vector, B vector, and C vector, and they are linearly dependent. Then, if I consider three scalars x, y, z such that they are real numbers, then if I have x times of a vector plus y times of b vector plus z times of c vector, and if all of them is equals to 0, if all of them is equals to 0 vector for, now if this statement holds true such that this x, y, z, these are real scalars such that not all are equal to 0, not all equals to 0. Okay, so there exists some kind of dependence or linear dependence between a vector, b vector, and c vector, right? So they are not all equal to 0. So maybe one of them is equal to 0, or maybe two of them equal to 0, but not all equal to 0. Okay, so that is a very important idea. Now, if I have this formulation of vectors as follows, then in order to find the value of alpha, beta, gamma, oh, sorry, alpha and beta, so what I need to do is, first of all, now there is one more condition regarding C vector over here. So if I use this condition, I'm going to get square root of 1 plus alpha square plus beta square, that is equal to square root 3. So from here I'll get one equation in alpha and beta, that is equals to 3. So alpha square plus beta square is equals to 3 is one of the condition, right? Now I will have another condition. I will also obtain another condition by using this particular identity over here. So if I use this, then x times of, so x times of, I will have this as I cap plus j cap plus k cap plus y times of uh, 4 I cap plus 3 j cap plus 4 k cap plus z times of I cap plus alpha j cap plus beta k cap, right? And this is equals to 0 vector, right? So if I have this, let us club the terms in x, y and z, or maybe sorry, let us club the term in the I cap, j cap and k cap direction. So if I do that, so in the I cap, I will have x plus 4y plus z, which is basically the I cap. And similarly, if I club the component in the y direction, that is for the j cap, so I will get the terms as x plus 3y plus alpha z, right? And similarly, if I club the terms in the k cap component, so I'm going to get 1 plus 4y, sorry, x plus, I'm so sorry, it should be x plus 4y plus beta z k cap, which is equals to 0. Now, if this particular vector on the left hand side is equals to 0 and is equals to the null vector, then all the components of the I, j, k should be individually equal to 0. Right. So if this all are equal to 0, then I will obtain three sets of linear equations. So I will obtain three sets of linear equations in three variable, which are as follows. Now from here, this is a question of set of linear equations, right? So if I have three sets of linear equation and all of them are equal to 0, so one of the trivial solution will be x, y, z, all of them are equal to 0. However, we don't want x, y, z to be equal to 0. So therefore, so from here, for non-trivial, so from here for non-trivial solution, so from here for non-trivial solution, in order to get the non-trivial solution, the particular determinant of the coefficient matrix, the determinant of the coefficient matrix like 1 4 1 1 3 alpha 1 4 beta, this particular determinant should be equal to 0. This particular determinant should be equal to 0. So if I solve this, from here, so let us try to solve this determinant. So I can do some row transformation to make it easy. So let us say row 2 goes to row 2 minus row 1, and similarly row 3 goes to row 3 minus row 1. So if I do that transformation, so it is going to be 1 0 0 and 4 1, it is going to be minus of 1, it is going to be 0, it is going to be alpha minus 1, it is going to be beta minus 1, and this determinant equal to 0. So therefore this result is very easy. So from here I will have beta equal to 1. So from this, if I solve this, I will have beta equals to 1. So once I get the value of beta equals to 1, and I also have another equation relating alpha and beta, which is basically alpha square plus beta square is equal to 1. So from here I will have the value of alpha as equals to 0. So sorry, alpha square plus beta square is equal to 2, right? Is equals to 2. So from here I will have the value of alpha equals to 1. So from here I will have the value of alpha also equals to 1. So therefore the value for alpha and beta is equals to 1. Sorry, it should be plus or minus 1, right? Because I will have alpha squared is equals to 1. So from here alpha can be plus or minus 1, right? So I will have beta equal to 1 and alpha have two values plus or minus 1. I hope this solution is clear to all of you. Okay, this is quite an interesting problem and quite an important problem, especially if you are preparing for your JEE Mains. Sometimes these types of questions are basically being repeated. Okay, this is very old IIT JEE problem. Okay, I have taken this problem for the JEE Advanced old paper. So I hope you can relate to this, right? All right. I hope this is clear. Attitude, boy, I would prefer say that please study. Okay. If you study, that would have been better. Okay, so I assume this is clear to all of you. If you are focusing on this particular part, I think this question is clear, right? And this is a very important problem. Trust me, these kinds of problems generally students don't even understand and they often tend to make mistakes. Okay, so the way I explained you the problem, I hope this is clear. And if you understood this problem carefully, then I think you will be able to solve any types of question based on this kind of vector formulation of the basics part. Okay, so just a note that if we have linear independent vectors, then if I have this kind of expression x a vector plus y times b vector plus z times c vector is equal to 0 vector, if it is linearly independent, then all x, y, z should be equal to 0. However, if it is linearly dependent as mentioned in the problem, so if it is linearly dependent, then x, y, z are real constants or scalar, but they are not all equal to 0. Kartik FF, thank you. All right. So please take a note of this particular part, and whenever you have any problem in the examination based on this kind, I hope you will be able to solve the problem if you have understood this part carefully, right? So with this particular understanding, let's now move towards developing the theory for product of two vectors. And today we're going to learn about scalar product. So let's try to discuss about product of two vectors. So let's try to learn about the product of two vectors, right? So let us understand first what do we actually mean by product, right? So if I try to explain you that product of two vectors is generally done in two ways, right? Now, why do we actually need to express the product of a vector, right? So there are certain situations in physics or where we need to explain or where we need to project one vector onto the another, right? So there have been some cases where we have tried to explore the projection or the length of the projection of one vector onto the another, right? So in that particular scenario, mathematician came up with the idea of developing the theory of product of the vector. So when the product of two vectors result in a scalar quantity, we call that particular product as a scalar product. And so therefore what I mean to say is that product can be done as two ways. So I can have one where the product of the two vectors is done in such a way that I get a scalar result, and such product is known as scalar product. Similarly, the product of the vector can be done in another way where I get a vector result. So that particular product is also called as vector product, right? And another name for vector product is cross product, right? And similarly for scalar product, the another name is also called as dot product, right? So today in our discussion, we are going to definitely focus on only dot products as of today's class, right? So in the next class, we're going to study about the cross product. So let's try to understand what do we actually mean by a cross product, by a dot product, right? Sorry. So let's try to explore what is basically meant by dot product or scalar product, right? So let me write over here scalar product, and let us take two vectors. So right now we are only exploring the product of two vectors, right? So if I take two vectors like this, let us say this is my a vector, and let us take another vector, let us say this is my b vector. All right. So if I have two vectors such that the angle between the vector is given as theta. So theta defines the angle between the two vectors a vector and b vector, right? Now, and theta is the angle between the vector. Okay, so theta is the angle between a vector and b vector. So theta defines the angle between a vector and b vector. All right. Now scalar product of these two vectors a vector and b vector is defined as, so it is written as dot of So when we write vector dot b, so it is referred to as a dot product or scalar product, and it is defined as mod of a vector multiplied with mod of b vector multiplied with cosine of theta. So where theta is the angle between the vector. So this is the result of how we define a scalar product, right? So this particular part, it refers to the magnitude, okay, or the length of the line segment. So length of the line segment of the vector is denoted by the mod of a or magnitude of a, right? So from this part, what we observe is that, and also please note that theta lies between 0 to pi. Theta lies between 0 to pi, right? I hope this is clear. Now, there are two things to understand over here is that, first of all, this modulus of vector is always positive, right? So the sign of this particular result or the sign of the dot product is totally going to be dependent upon this particular term, right? So whether I will have cosine of theta positive or negative, that will determine that the value is going to be negative or positive, right? So therefore, if I say that my theta is an acute angle, if my theta is an acute angle, that is your theta lies between 0 to pi by 2. So if my theta lies in between this particular range, then I will have cos theta greater than 0 or cos theta is positive. Therefore, what I can say that if I have an acute vector, then the scalar product is going to be greater than 0 or positive. So if I have the scalar product which is positive, then I can say that the theta or the angle between the vector is an acute angle. Is this part clear? Similarly, if theta is obtuse angle, if theta is an obtuse angle, that is, it lies between pi to pi by 2 to pi. In this case, I will have my cosine of theta to be negative, right? Because it lies in the second quadrant. So cosine of theta becomes negative. That means that I will have the dot product or the scalar product to be negative as well. So whenever my scalar product is negative, that basically means that the angle is an obtuse angle. So I hope this particular thing is clear to all of you, right? And this particular result is obviously a scalar real result or scalar result, right? So, and also we know from trigonometry that cosine of theta, the mod of cosine of theta obviously lies between 0 and 1. So the maximum value of cosine of theta lies between 1. So from here, I can make another statement that the scalar product is obviously less than or equals to mod of A multiplied with mod of B. So there is a strict bound on this particular scalar product, that is, it is obviously less than the product of the magnitude of these two vectors. Okay. I hope this is clear to all of you. All right. If you have any problems, please let me know in the live chat. Nishant, Nishant Kumar, thank you. Okay. So if you have any problems, please let me know so that I can help you out with your queries. Please let me know if you have any questions. All right. So I assume this is clear. So let's now move on to understand the importance of this scalar product or the application side, right? So let us try to explore the geometrical interpretation. So let us try to explore the geometrical, let us try to explore the geometrical interpretation of scalar product. So let us try to explore the geometrical interpretation of scalar product. So if we try to look into the geometrical interpretation of scalar product, one of the obvious result is that, so if we look into the definition of scalar product, what we have seen is that A vector dot B vector is basically given as mod of A into mod of B into cosine of theta, right? But theta is the angle between the vector. So let's say that I know how to perform A vector dot B vector, and I just divide this particular result by the magnitude of A vector and B vector. Since these are real numbers, I can divide it. So this will result me the answer for, so this will result me the answer for cos of theta. So this will result me the answer for cos of theta. So if I need to know that what is my angle, let us say I know the result for the dot product and I know the result of the magnitude of A vector and B vector. So in this case, I can easily find out the theta as cos inverse of A vector dot B vector divided by mod of A vector into mod of B vector. So this result is going to give me the angle between the vectors. So if I want to know or find out for two vectors, if I want to find out the angle between the vector, so I can easily use this particular approach. Now, why we give this particular expression, you must be having this question that how can we have the knowledge of the vector dot product without even having the angle? Well, the answer to this is very straightforward and obvious, is that let's try to understand that how we can calculate the A vector dot B vector result without even knowing the angle between them. So let us say that I know my A vector, which is given as A1 I cap, A2 j cap plus A3 k cap, and similarly I know my B vector, which is given as B1 I cap plus B2 j cap plus B3 k cap. So let us say I know the components of the A vector, I know the vector which is A vector, B vector is given in this component wise, right? So I know the A vector and B vector. Now if I need to perform the dot product, so the dot product in the component wise is basically given as, so it is very simple. It is given as, so it is given as A1 B1 plus A2 B2 plus A3 B3. Now how are we getting this result? Let's try to understand. So if I try to understand this result, so we need to explore one more idea, is that now if I ask you that if the angle between the vector is 90 degree, so what do we actually mean that if two vectors are perpendicular, right? So if I say that I have two vectors, big pankha, sir, I'm in class 12th, my only class 12 syllabus is done till JEE mains level. In fact, I'm going on with my course of PW class. My class 11 is full. See, big pankha, what I can suggest you is that right now in this moment, please contact me on the number and get access to the online batches. Okay, so one-to-one batch is definitely going to help you out, right? So if you I'm just going offset from this particular topic, but still, so let me show you the contact. So all right, so please contact us on this particular number. So in order to complete your class 11th, okay, so in these 3 months, if you want to finish your class 11 backlogs, you can contact me on this particular number and I can help you out with the one-on-one sessions. Okay, so please contact on this number to get access to the one-on-one backlog lectures. Okay, so I hope this is clear. Is this part clear to you, Big Pankha? So please take a picture of this number and you can call me once whenever you are willing to, right? So please take the help of this backlog clearing classes. Okay, these are basically done to help you out with your backlogs only, right? All right, so let's return back to what we were discussing, right? So I asked you this question that if I have the vectors are perpendicular, so if I have the vectors, if I have my vectors are perpendicular to each other, then the angle between the vector is going to be pi by 2, right? So if my angle between the vector is pi by 2, then from definition, then my cos of theta is going to be 0. Therefore, my A vector dot B vector is going to be 0, right? Now, if you remember that I cap and j cap denotes the unit vector in the x and the y cap direction. So they are mutually perpendicular to each other, right? So they are orthogonal vector. So even if I take the dot product of I cap and j cap, I'm going to get the answer as 0. Now similarly, my k cap denotes the vector in the z direction. So I cap dot k cap is also going to be 0, right? Also we are going to also have the result for j cap dot k cap is also going to be 0. So these are the following results that when I take the dot product of two perpendicular vectors or orthogonal vectors, they are going to be 0, right? Now, and one more thing is to understand is that if I take the dot of the same vector itself, so if I take the dot product with the same vector itself, I'm going to end up getting the magnitude of the vector, right? Because in this case, the theta is equal to 0 degree, so cos of theta will be equal to 1. So cos of 0 degree is 1. So therefore, this is going to end up getting the magnitude, right, which is equals to 1. So I cap dot I cap, similarly j cap dot j cap, similarly k cap dot k cap, all this result is going to be equal to 1. So this result is going to help us to understand that how we perform this particular operation. So over here, if I do the a vector dot b vector dot product, so when I do the multiplication, let us do the multiplication component wise or one by one. So if I take this particular term and I multiply with this particular term, I'm going to end up getting a1 into b1, these are the constants, and I cap dot I cap is going to be 1. Similarly, if I take this particular term and I multiply with b2 j cap, then the result, that is I cap dot j cap, is going to be 0. Similarly, if I take this particular term and I take the dot product with this particular term b3 k cap, again I'm going to have the answer as 0. So if I do this particular product by taking each component twice, so definitely the result is going to come out something like this. All right. I hope this is clear to all of you. So from here, we can definitely use this particular result to find out the answer for the angle between the vectors. So if I know the components of the angle between angles, I can easily find out that what is my angle between the vectors, right? So this is going to be a very important concept, and we're going to definitely use this particular concept in almost every problems of vector algebra, right? So you're going to see that if I take up the JEE Mains problem, so when I'm going to take up the JEE Mains problems in the later stages of this course, so definitely you're going to see that there are a lot of question or lot of chunk of problems that will definitely use this particular idea to find out the angle between the vectors. I assume this is clear to all of you. So let's now also discuss about one more topic, that is called as the projection. Okay, that is called as the projection. Okay, so if I need to find out the length of projection, that is also basically being found out by using the scalar product. So let us try to understand how. So if I have, let us say this is my a vector and this is my b vector. All right, and I am asking you the question that what if I project this b vector and let us say this angle is theta. So what if I project this particular vector on the a vector and I want to find out the length? So let us say if this particular vector is projected on the a vector, so this is where the projection will going to lie, and this particular length will denote the the component of b vectors projection. So b vectors projection on a vector. So this is going to be this particular length is going to be the b vector projection length on the a vector, and we also denote this by b parallel like this. Okay, b parallel, right? And similarly, if I talk about this particular length is also called as a perpendicular. So the perpendicular component of the projection vector is given by this particular length. Now the question over here is that how can we find out the following lengths or the following vectors? So in order to do that, the easiest way to understand this is that if this particular length denotes the magnitude of the b vector, right? So if I need to find out this particular length, which can be simply given out as, so this b parallel length is can be simply given as mod of b times of cosine of theta. Now we have seen that cosine of theta can be given as a dot b divided by mod of a mod of b. So if I do that result over here, so the length of the projection is going to come out simply as mod dot product of a vector and b vector divided by the mod of a vector. So this is going to result in the component of the vector projection. So b vector, if it is projected onto the a vector, the result is going to be like this. So this is the projection of B on A. So whenever we are projecting some vector on another vector, that the result is very easy to remember. It is the dot product of the two vectors divided by the magnitude of the vector on which you are projecting it, right? In this case, you are projecting on the A vector. So the dot product of A will come in the denominator. Now, how to find out this B perpendicular? It is very easy. Now it's a right angle triangle, so we can use our Pythagoras theorem to find out this result. So B perpendicular will come out as square root of mod of B vector whole square minus this particular result. Alright, so this is going to give me the length of the component of the perpendicular projection. I hope this is clear to all of you. Alright, so this part is clear. So if this part is clear, then the most important part of understanding about the component or the geometrical implementation, I think it is clear to all of you, right? So this will basically help us to understand in solving questions regarding vector products. So why do we need to understand this particular part is that in lot of questions or lot of questions of 3D geometry, we'll see that the projection concept is going to be very, very important. Okay. So for learning about that, also in ray optics, this particular concept of projection is a really important concept, right? So I hope this particular thing helped you up in understanding about this particular concepts. So in our upcoming class, we're going to discuss about some of the important problems on vector dot product or scalar product, right? And then we're going to start with our discussion of the idea of cross product, right? Thank you, Rajat. I hope this is clear to all of you. Is this part clear? Is this part clear to all of you? Any questions, please let me know in the live chat. If you have any questions, please let me know in the live chat. Okay. However, these concepts are going to be very, very important. Okay. So please take a note of all these concepts and try to use them as and when needed. Okay. I hope the understanding has to be clear. Then you can solve any types of question. Mindex Sen, IITB. Sir, I'm in class 10th, covered vectors and motion in straight line. What you suggest? I do more chapter and less perfection, do more question or less chapter, but only lecture and few questions. See, if you are in class 10th, I would say please explore all the aspects of it. Okay, it's not like going for I would say better go for perfections. Okay, so please try to understand the concept in a better way and then move on to solving questions. Okay, once the concepts are clear, once you have a in-depth knowledge of the theory, I think you can then solve any types of question. Okay, so it doesn't matter about practicing a lot of question. If your concepts are clear and if you practice some question regarding that particular concept, then it will help you out in solving any types of question. Okay, so please make sure that you go towards perfection. Okay, all right, is this clear to you? Mindex. All right, so with this part, let's conclude our session over here. And I thank you all of you for your wonderful attention. And I hope to see you up in our upcoming discussion. So tomorrow, again, we're going to have a lecture where we're going to discuss about some of the important problems of scalar product. And then we're going to also explore the idea of cross product.